Hello everybody and welcome back. So we're going to be continuing with our who.palm template lessons. This one we're going to particularly be focusing on the actual who.palm template class instead of the palm template group. Because at this stage we should now know how to access a palm template group, whether it's a pre-existing one or creating a new one, and whether we are grabbing it from a node or from an HDA definition, and then also we're able to set it either as the spare parameters on a node, as the spare parameters on an HDA, or the definition of the HDA. So we sort of have three options there. Right, so now that we're able to do all of that, and to be honest, that is probably the most complex part of working with parameters and Python. And in fact, I mean, it's Python. It's just working with Houdini's rules. So it's Houdini that kind of has a complex way of working with parameters. But if you can sort of grasp the previous lesson that we covered, then technically this one should be a lot easier to understand. There are some tricky bits to it, but for the most part, it's actually sort of the most difficult bit is understanding how the palm template groups work. The palm templates themselves are just kind of filling up the palm template group. Okay, so as I said before, the palm template group is this section in the middle, really. The stuff on the left here, these are the palm templates. So exactly as we would do it physically, manually, where we click and create and just drag something in, or obviously like sort of add it with this arrow or whatever. We can drag in folders and we can drag in like a float and set its parameters on here. Okay, so that's kind of exactly what we're going to be doing now. It's just creating these different palm templates. You get different types, so obviously for all the different types that exist in Houdini, all the data types and sort of even subclasses of that. And then there are also the list of kind of properties that define how that parameter works. Okay, so that's basically all we're really going to be doing. Okay, so one thing that we always start with how to use functions to grab or to get data. So to get the reference to a parameter that maybe already exists. Okay, obviously we can create blank palm templates, but we're going to start by kind of grabbing palm templates that do already exist. However, before we start with that, I want to make it very clear, and this is probably the most important thing to understand about working with these palm templates, is that when we get them, so we sort of reference one of them that already exists, what we're grabbing is not a reference to the actual palm template that exists, but rather we grab a copy. It does specify that if you do read the help file, it will kind of, it talks about somewhere in this giant wall of text, it talks about how it grabs a copy of the palm template instead of an actual, direct link to that raw palm template. So for example, if we go and change it, in fact I think it's this paragraph over here which talks about how if we go and find the who.palm template, we cannot just modify it. If we modify it, it modifies the copy, sort of like frozen geometry. So when we go and grab frozen geometry, we can manipulate that, but it doesn't alter the original geometry. We have to go and actually make changes to the original. In this case, what we do is we grab a copy, we alter it, and then we go and replace the original. That's the way if we want to kind of manipulate something that already exists. Alternatively, we can just remove something that exists and add in our own one if we're wanting to change it a lot. Okay, so with that one out of the way, the rest of it is relatively simple. Okay, so what we want to do is get a reference to these parameters, a copy to the reference really. Okay, so in order to do that, we need a palm template group. So we handled that in the last lesson, so we should be able to just go and grab a palm template group reference. let's grab the HDA definition reference from this one, because this has a few parameters that we've created and then a few other ones that already existed before. Okay, so in here I'm just going to say I'm going to grab a reference to my node, so n equals that. I'm going to grab my definition, which is n.type.definition, and then we're going to grab the group, so I'm going to say group equals definition dot palm template group. Okay, so now let's just double check that that has worked. If I print group, it's going to print that palm template group. Now if I want to find a node, a parameter inside of this palm template group, because right now this object contains all of the data that is inside of here. Like I say, if I go here, it's this list, but well, we want to actually look at not the list as an entirety, but actually start going through and finding individual things. So I want to go and actually find this parameter. So what we can do is use the find, so group.find function. Now this is a function that exists within the palm template group class. Like I said, we're working mostly this lesson with palm templates, but of course we're going to need methods within the palm template group class, because a lot of these methods will grab references to a who.palm template. Okay, there's always a bit of a hierarchy, and so we use the node to grab palm templates, and we use palm templates to grab, palm template groups to grab palm templates. Okay, and so on. So in this list over here, we have a few things that allow us to sort of get, go and get palm templates, right? Now, a lot of the time there are sort of almost redundant amount of methods. There's kind of a smaller group of ones that you use often, and then a lot of them that are very corner case. But with the palm template group, I actually find that almost all of these are useful at some point. So I'm going to go through probably quite a few of them, but any that I don't go through as well, I would go and read if I was you, because these are all very, very useful to know. So we're looking at the find one first. Now all we need to do is give it a name, and it is actually going to search the group for a palm template whose name matches the specified template. Okay, well, the specified name. So the one I'm looking for is called palm2. Okay. Now, obviously, I would encourage you guys to never just, drag things in, actually give them proper names, because you'll regret it later if you don't, when you're wanting to reference things with scripts, because it becomes very confusing when it's called palm, palm2, palm3. It's really bad. For this case, it doesn't really matter, because when I'm using this, I just want to show you how the functions work. So we just feed it the name, so palm2, and then when we say apply, what this has done, you'll see it's printed with the triangular sort of braces over here, so we can see that this is an actual object, and it's grabbed a who.float palm template, and then it tells you it's got its name, a label, it just basically gives you some information about this. But again, this is just the way that it is represented, so the repr function. We can, once we've grabbed that reference, we can manipulate that using the palm template class. Now, I just want to point out that the palm template class is a parent class, which you need to look at this inheritance list and see that there are all of the list of possible templates here. So this list on the left, all the types exist here under this palm template class. So the parent class will have certain functions that apply to all of those. For example, grabbing the name or label, because every single one of these has a name and a label. Okay, every parameter, no matter what, has to be able to have a name and a label and a type. Okay, so it has all of these, but then if there are different sort of sub methods that only live within one of these, then they will live only in that subclass, not under the parent class. Okay, and what you'll see is here, what it really returned was not actually an instance of the who.palm template class, but actually a who.float palm template. So you can go and reference the actual palm template itself, so the who.float palm template, and we can look in here for a much more detailed list of exactly what we can do to it. But you'll see that that still does list the methods that come from the who.pom template. So some of them are inherited methods, and then others at the top here are unique methods that are unique only to the who.floatPom template. Okay, so just so you know that that's how this is working. Even though we're using functions inside of POM template, really it's grabbing subclasses. Okay, so that's one way to grab an actual reference to a parameter. But remember, I'm going to remind you guys one more time, this is a copy of this POM. So if I go and alter this and change, for example, the label, it is not going to go and change this label. Even if I went and set the group, okay, because remember we've grabbed our group, but our group is like this. We can make alterations to it, but we have to apply before that will take place. And applying, the equivalent of applying is going and setting the POM template group. So when we go definition.set POM template group, that's us clicking apply. But if I went and altered the label of this POM template, it would not alter this one, because this is a copy of this, right? We have to go and actually replace this one with our altered copy in order to do anything with it. It's kind of like creating a photocopy, then making change to that, you know, maybe sort of adding a little bit or scratching something off, but then you still have to go and replace the original with the copy. Okay. Right. So that's find, and then also there is a find indices. Now find indices is kind of interesting. What it does, it's still looking for a particular POM, okay, POM template. But what this is going to return, instead of a who.pom template type, an instance, it's going to return a tuple of integers. But these integers correspond to essentially its hierarchy within the HDA. Okay, so let's go and do this. We go group.find indices and we feed out our POM2, and let's see what this prints. Now it prints 0, 0. What does that mean? Well, if we go to our definition, which is exactly where this is, and also I'm just going to make sure we click show invisible parameters, because it does include invisible parameters. So do not make the mistake of forgetting to tick that on, because otherwise it may be confusing why it says 0 where actually you might think it should say something else. So what the first 0 means is that within the root, okay, within root, which template is this in? Okay, if our float, our POM2 was there, then it would just return 0. Okay, because it's the first index in this root. But it is inside of a folder. So it is inside the first folder, which is called 0, the first index. And inside of that, it is the first index. So 0, 0. Let's say we went and added another folder over here. And for the sake of demonstration, I'm going to make that folder invisible. So when I click apply, right, you'll see that we don't actually see a new folder, but technically there is one. Now when I run the same expression, it's going to say 1, 0. This means that if we show here, this folder in root is 0. This is 1 because it's the next index in our list of parameters. Okay, so if we collapse everything, you can see this is 0, 1, 2, 3, 4. Okay, and they're counting parameter templates. Okay, that means folders and non-folders. Okay, so let's even go and add another one. So we're going to add a float here, then there's a folder which is invisible, then there's our folder which has POM2 in it. Okay, if I now do this and run it again, it's going to say 2, 0. That's because index 0 is the label, well, this float. Index 1 is the invisible folder, index 2 is this folder, and inside of 2, index 0 is the parameter that we're looking for. So it's essentially giving us a path to that parameter, but using a hierarchy of indices. We could make this a little more complicated by putting a subfolder, putting it in there, then throwing a few other floats in here with it. Okay. And so when we say accept now and we click apply, it's still going to find it, but it's at 202. Okay. So in other words, if we show invisible, 0, 1, 2, then 0, and then 0, 1, 2. Okay. So that's how the indices work. Now, I know this, a lot of the time you're going to want to return the actual parameter template if you want to make alterations to it. So find is going to be probably most commonly used. But you also very, very often are wanting to find specific parameters at certain locations in the hierarchy. Also, once you have found that parameter template, you can grab its hierarchy of indices and use that as essentially a location to say which parameter should be replaced. Okay, so if we want to grab this parameter, make alterations to it, and then replace the original, well, knowing that it's at 202 helps us find the original where we want to go and swap it out for our altered version. So this is one very useful way of working with the location within these parameters. Okay, and also please don't forget that folders count as PALM template groups. PALM templates, right? They are the same as any other PALM template. It's just that they also can include PALM templates inside of themselves. They still form a hierarchy, but they themselves are parameters, basically. They're just parameters that have no actual slider. Okay, so that's find and find indices. Now, we can also get entry at indices. So this is kind of the opposite of using or asking for the list of indices. Is instead we can give a list of indices, and then it's going to return the PALM template that's at that hierarchy location. So, for example, we know that our location of PALM2 is 202, right? Now, let's say we had used our script to go and actually grab this value. Well, now we can go and return the template. So as we're converting back and forward between them. So we can feed it a list. Now it wants an actual list, so we put that in brackets, and we just say 202. And then what it will do is return that float PALM template, which is PALM2. Okay, so we tell it the location, and it goes and fetches the actual PALM template. Then another way of kind of working with the parameter templates that we have available to us is through the entries function, the entries method. Okay, now entries is going to give us all of the entries, right? So everything in the PALM template group. Okay, now I'm just going to import our pprint, because when we have a list like this, it's much harder to read. So let's pretty print this, and then when we click apply, now do you notice something here? I would have expected to see a lot more PALM templates printed than just this small number. Okay, but the entries function sort of stops at each folder. It stops at the folders, and each folder is then a PALM template which includes a list of PALM templates. So the entries themselves have sub-entries, right? When you run entries, it just returns everything in root. And then what we can do is on the PALM template, so on the folder PALM template, we can search for the entries, right? So let's come in here and look at our list of PALM templates, and actually you'll find folder PALM template is one of them. And if we come to this, you'll find in here that we should have PALM templates. Okay, so let me just show you something in this over here, which is our PALM template group class, which is where we have this entries function. Okay, so there is entries there. But also, in fact, if I scroll down to find entries, because I think they've included it near the, there we go. So you'll see right here next to it, entries, underneath it is PALM templates. These two are exactly the same. It says here that this method is simply an alias for the entries method. Okay, but in our folder palm template, you'll see that there is no entries. Okay, and yet there is a palm templates. So although it's an alias, it's kind of a little confusing, because the fact that this is the alias of this makes you think that, well, this is the one that they would prefer you to use. This is the whole explanation, whereas this is just an alias for that other one. But the folder palm template only has the palm templates function and not an entries one. So basically you can use either one. Personally, I've gotten into the habit of using palm templates because it actually does make sense to me. Look, I'm looking through this route for a bunch of palm templates. So kind of makes like verbal sort of sense to me, but also it's easier because it literally is the same as the method inside of the folder palm template class. Okay, so if you're welcome to use entries, but I always just use palm templates. And so what we could do is loop through all of these folders here, and for each one then grab a list of palm templates. And if there are any subfolders in that, then we could loop through those. So we can kind of recursively loop through all of our palm templates, saying if they're a folder type, then loop through its palm templates as well. And you can keep going down and looping through the hierarchy. Okay, so that's just one way of sort of working with these. Like, let's say we wanted to go through and actually duplicate all of them, but maybe make some sort of change. Well, then we would create some kind of recursive loop. Okay, so that's entries or palm templates. It'll give you exactly the same. So I'll even show you that. We can say palm templates and it will do exactly the same thing. Right. Then there is also very important, since we're talking about this route and having all of these entries inside of there is also one which is entries without folders. Okay, so this is just returning sort of all of the ones that are in root and not like that don't have folders. So entries without folders. Okay, and then it's going to return everything, but it's not including the folders. Okay, and in fact, I mean, we're pretty printing here, so it's putting it under one another, but because there's not enough horizontal space, it's kind of a bit of a mess. But let's try and shift this all over, and you can kind of see that it's printing everything, right? So it is going to print every float that we have, every, I know it's a little bit hard to see, but if we, like, let's here we went and printed maybe the len of this. So instead of that, let's print the len of this, just so you can see how many total entries we actually have. Then there's 42. Whereas if we just do entries or palm templates, then you'll see that there are 6. Okay, so both of those are ways of working with it. Normally, actually, I know it seems easier to just loop through all of the entries without folders, but that's the one that's probably the least used, because normally you do want to respect the hierarchy and you want to manually have to loop through the hierarchy, because you actually want to recreate the hierarchy if you're going to be rebuilding these parameters on another node. So a lot of the time we will do the kind of what seems like a longer route, and yet, see, if we had to just grab this list of palm templates and recreate them on another node, well, now they would all be loose. Now we have to figure out with each one, we've got to find its hierarchy and then rebuild its sort of parent folders. It's a real pain, so it's much easier to actually just traverse the hierarchy slowly and grab those palm templates. Okay, so that's how we get parameters. But there are also a few functions that allow us to get folders as well. Although folder palm templates do count as palm templates, so when we do something like palm templates or entries, they do appear. There are also other ways of grabbing them, and the reason for this is because of a slight difference you'll notice when it comes to palm templates and folders. So let's actually go to the type properties, and I'm going to show you what I mean. So when we create a float over here, it has a name and a label, okay? Whereas when we create a folder, the label is all that actually matters, right? You'll see here the name is actually grayed out, okay? Now inside of here, we can change this name, but a lot of the time, the names, especially on root level here, these are all locked. So it's basically in fact, I'm not even sure why these get locked, but basically names of names of folders are not what we use to refer to them. Because you also, if you notice in your actual parameter list over here, if you hover over a parameter, it tells you its name. So if I want to write some script and just really quickly go and reference this parameter, I can drag it in and say .set to something like 10 or whatever, and it goes and sets it to 10 because I know what its name is. But I can't do the same with folders. I can't drag them in, I can't hover over them and it shows me their name. It just kind of ignores them. The only thing that's important about the folder is what it contains, of course, and then its actual label, not its name. So it's the one sort of exception to the rule that, I always say that names are the most important. Labels are just for humans to read it. So your user can read the label, but the name is what the script cares about. In this case, it's the other way around, okay? And we only really care about the labels of the folders. So you'll notice that even when we do go and create folders, if I'd go and drag in a folder, I don't even ever bother naming the folder. Yeah, you name it as in you click here and type a name, but this is a label, okay? You see, when you name it there, it changes the label. The name is not changed. You can come in and change the name if you want to, but really it doesn't matter, okay? So there are a few methods here that allow us to grab folders. So one of them is find folder. So you'll see we have got find, where it wants the name of the PALM template, but here find folder lets us give it the label or labels. Now what does that mean? So let's have a look over here. I'm going to say group dot find folder. Now if I give it the label, okay, so I'm going to just kind of put that away and we're going to look at this as an example, right? Now this one is called folder name, but this one here is also called folder name, right? With names they have to be unique, with labels they do not. So how does Python know the difference between that folder name and that folder name? Well, it doesn't know the difference, but that's why this method requires us to feed it a list, which is essentially a path, almost like when we had that list, that sort of path of indices. So 202. Well, if I say, okay, go and find the folder called folder name, like that, okay, so with actual capital letters and a space, this is the label, not the name. So I feed it that and say apply, it's going to find one. But which one is it finding? It's found this top one. It's found the one in root only. Okay, and we actually know that because it's literally called folder 2. So let's come and have a look at which one this is. And if we go to this one, folder name, okay, we'll see, okay, hang on, it has been renamed in here. That's interesting. Let's see if here it appears. Folder 3. Yeah, you see what I mean? Like where the folder names keep just getting renamed. I mean, they're different depending on whether we go to the spare palms or not. So basically, this is not even reliable. You can't even rely on that. But basically, this one that it has found is this parent one, the top one. If we wanted to find this one, we have to actually tell it where to look. Very similar to when we did the list of entries, it only found 6. Well, it only looks in the top level. So we could find folder name, we can find transform, we can find render or misc. Okay, but what if we had another folder inside of this one? Something, and let's give it an actual name. So let's call it something. Okay. Well, then when we go, okay, find something, right? It finds none. And it has found none because we haven't given it the path. We literally haven't given it the ability to go one level deeper. What we have to do is give it a list. So now if we say, okay, go find folder name, comma, something, okay, and it's done in this way. It's not done where it's sort of got a slash, so it's one string with separated by a slash. This is not what it's expecting. Instead, what it wants is a sequence of strings that relate to label names. So it's going to go inside of folder name and then find a folder called something, right? So now when we click apply, it is not working. That's interesting. Hold on, let's work our way through. So we've gone group. Okay. Inside of here, there's something called something. Let me try something over here. Let's just move this to folder name. That still finds nothing. Okay, that's interesting. Hold on. I think this might have just gotten confused with itself. So if we just disable and re-enable it, still no, right? Right. Let's go and just redo this. Let's just double check that this is actually referencing this right node correctly. So let's let's reference that node. Okay, and we can print in. Okay, it's printing that. Then we print its definition. Okay, so it's printing that definition on disk, which should be saved. We then print the group, right? And then we can say print group dot palm templates. Okay, in fact, we'll pretty print that to make sure so we can see the list of labels. Okay. And one is called folder name, a folder name. All right, so this technically should work, right? Print folder name, folder name. So we're going to go inside of this one, and then into that one. Okay. Oh, I just realized. If we show invisible parameters, you see this one. This is actually a really good example to show you how this works and how complicated these PARM templates can be. So be very, very careful. Invisible parameters still count. Okay, and I just told you that like 5 minutes ago, and now I've gotten tripped up by the exact same thing. This invisible per folder is also called folder name. Okay, so that's a lesson to you. Name your folders something other than a generic name. But it's good to know how this works. So when we say go find folder name, the first one that it's finding, it actually finds not only the, so it uses a hierarchy to avoid there being issues with duplicate names. But if it does find duplicate names on the same level, it takes the first index found. Okay, so it's hitting this invisible parameter, going inside of it and saying, well, there is nothing inside of there called folder name or something, so it's not finding the folder in there, and it's returning none. But that's because we were assuming, with that being invisible, I was assuming, okay, it's hitting this one and then should be going inside and finding it, but it's not. Okay, so that's a little bit of a bug, but, well, not a bug, it's a mistake, and you should be very much aware of that. Okay, so if you do come across anything like that where it's not finding it, you might be hitting invisible parameters. So maybe be very careful to use find folder, right? It is, you have to be very specific about what you're doing. So now once I've removed that one, because folder name is now the first instance of the label folder name that it will find, it should now find my sorry, let me remove my pretty printing over here and just print the one folder instance. So there we go. It's finding my folder name inside of the folder called folder name. All right. Instead, if I went to now put this to something, it's going to find that folder that we were looking for. So inside of folder name, inside of there's a folder called something, and it's finding it now. but it was not finding it before because there was another instance of folder name that was higher up in the list. If this was over here, then it would still find it. Okay, if we go click apply now, it'll still find it. If we move this to there, then I think it will say none. Yes. So it's actually important to note that it is the current hierarchy and not, it doesn't care the order that the parameters were added. It just literally looks at the index order. Okay. So let's find folders, and then you can also find indices for folders. So it's the same thing, but instead of returning a reference to the copy of the folder pom template, instead it's find, well, this is called find indices for folder, and then you still give the same path to that folder, and what it's going to return is instead the indices to that. Okay, so 1 1 meaning that it is the we have no invisible parameters. This is 0, this is 1, and inside of that, this is 0, this is 1. So we're saying go find folder name something, and it's telling us exactly where it is. Okay. So that's find indices for folder. Now there is also another useful one, which is containing folder, right? Containing folder. Now what this does is we need to feed it a pom template or a name. So the same way where we would do group.find. So for example, we can go here, find, and then we can reference maybe this one, so pom5. So we say go find pom5 and tell me where it is, right? So, well, return it. Okay, so this returns a copy of pom5. Instead, if we now say go find the containing folder for pom5, then it's going to return the folder which is labeled folder name, because that's actually which one this is inside of. Okay, now it's returning this one, not the root. We could then do the same thing to this. In fact, I believe you can do it to group pom template. So let's try this. We say group.containing folder of the group.containing folder. So it's essentially running this one, looking at the group and finding the containing folder for pom5, and then using that pom template and finding the folder that contains that one. Not sure if this will work, but let's give it a go. There we are. So it does work. So it returns folder name, okay, which is this one on the top. Okay. So a little bit confusing though, this whole nested thing, but yeah, it's possible. Okay, so now that we know how to get a pom template that already exists, we also need to sometimes, in fact quite often, we're going to create pom templates. Now, I first want to talk about cloning them. So what you can do is once you create a pom template, if we want to maybe take this pom template and then create multiple copies because we want to start from, you know, let's say our pom5, right? So we've got this pom5, and we think it's a perfect template that we want to duplicate and then alter each time. Instead of having to sort of, when we grab a reference to it, it's creating a copy of the original. But now if we want to copy that copy so that we can sort of alter each one individually, there is a clone function. Now this is a method of the pom template class. So, and it's the pom template, not the sub classes. So it will exist on those subclasses because it will be inherited, but really it is a top level method for that class because all pom templates can be cloned. So it returns a copy of the pom template. Okay. So then you basically create a copy of that, and now you've got two copies with the original copy and then another copy. It's like literally making a photocopy of a photocopy, but now you can alter each one separately and then go and maybe add them to this pom template group, and now you'll have, you know, two new parameters, but based on one original. Okay. So now let's talk about creating our own custom, brand new, clean pom templates. So let's come to the pom template class and have a look. So this is our list of subclasses, and there is no constructor, there is no init magic method for PARM template. Okay, so that means that we cannot run it. We can't go who.PARM template and then with round brackets run PARM template. It says that there is no constructor defined, but because it cannot find the underscore init method. But the subclasses do have init functions, which means they do have constructors. So we can create a float PARM template by simply calling the float PARM template class as a function. And then when we do so, it runs this init function. So if we want to look at the arguments for what we need to define the sort of an instance of this float PARM template, we look at the init magic method. Now you'll see there are a lot of arguments, okay, and you will find that true of most of these, like almost all of them. I think the separator is probably the one that has like the least arguments. Yeah, even that has 3, okay, but they're going to have a lot because really it's about all the customization that you can do. I mean, look, when we go and create a folder like a float template over here, look at all of these options, right? There's a lot of stuff that we can customize here, and in fact there are even more options than is available to us when we initialize it. So sometimes we have to initialize and then still go and set additional data later on. Okay, so a lot of it has defaults though, so you can skip a lot of it, but I would read through every time and double check what it is that you're wanting to set. So float is one of the easiest ones, so we're going to use this as an example and go and create a float PARM template. Okay, so we'll do it in our Python source editor over here. Okay, so we still have a reference over here to our original PARM template group on our actual HDA definition of this node. What we're going to do is go create a brand new float PARM template, and then we'll add it into this group and then set the group, okay, as we learn those functions. So the first thing we're going to do is create a brand new one. So I'll call it my float or something, because we want to create this, but we need to store it in a variable before we then go and add it into the group and then set the group into the definition. So we say my float and then we run the actual class. So we say float PARM template like that, and then with round brackets we're going to call this. It needs a name. Of course, every parameter needs a name, so we're going to go and call it again, we'll call this my float, right? It also needs a label. We have to go and give it a label, and it does not have a default, so we do have to definitely go and give it a label. So we'll say my float, right? And label has space. It will accept spaces and capital letters and stuff, but with names I always like to keep it all lowercase and give it either underscores or just one word. Okay, and then we also need to give it a number of components. Okay, so what size is this float? Now in here, when we drag in a float, it assumes that its size is 1, but that's because there are multiple templates. So you see this list on the left is longer than this list of inheritance, but it's because some of these actually appear multiple times. Float vector 2, float vector 3, and float vector 4 are all the same thing. It's just that they have a different default size. So as we drag it in, it's going to have a different size. Well, this is actually a PARM tuple, right? But it still is basically the same thing with a different size. Now we can just take this float and set its size to be greater, and it'll basically be the same thing. And that's what we're talking about here, the number of components to it. Okay, so in this case we're just going to say 1. Now we can go set a default value, which is like setting the default value over here. Under channels we can set this default value, and of course if we've set a number of components to be greater than 1, then we would go and have a tuple, so it would be like, 1, 1, 1 if we wanted to set the default of a 3 float vector to 1, 1, 1. There's also a minimum and a maximum value, right? That's for each of the components. And then a min is strict, max is strict. That's if we go and set, so you know here where we go and set a range. So on a float we can set a range. This is the min, this is the max. And locking those min and max, whether that is on or off, that boolean is this over here. So min is strict, max is strict. They're false by default, but if we want to lock those, we can set those to be true. Then there's also a look. So this is a different, if we come down here, you'll see under look, there's a who.pom template look. Okay. And if we click on this, here you'll see this module, right, is where we can define how it looks. Okay, so does it look like a vector or an angle, or is it regular or logarithmic? Okay, which, see, with the logarithmic one, the slider changes to a logarithmic scale. So if you've seen with the especially with the integers, you can actually see it where the sort of division lines are evenly spaced versus if it's on a logarithmic sort of scale. So there's lots of cool things we can do to it, right? But obviously we're just going to kind of keep ours as basic as possible for now. There's also a naming scheme, which by default is XYZW. Okay, so as we increase the number of components, they will change to XYZ. So then when we want to refer to that, let's say our first float in the list, it would be X. So it will be my float X. Whereas if I choose a different naming scheme, we can choose 1, 2, 3. In fact, let me show you the naming scheme. So if we go here and then we click on the who.pom naming scheme, right, you'll see that there is base, which sets it to 1, 2, 3. There's XYZW, XYWH, right? That's a strange one. UVW, right? RGBA, that's for our color. There's min max, max min, start end, and begin end. Okay, so these are the different naming schemes that we can use depending on how we want our individual components to be named. But by default, it's going to be XYZ. Okay. And then let's see, naming scheme, disable when, and there will also be a hide when. That is this over here, so disable when, and we can type it in that sort of format where we've got the curly braces and then we refer to something else saying, oh, when this toggle is true or false or whatever, then we disable that. There is also is hidden, so if the parameter is invisible or not. Is label hidden, that would be, so over here on our float we can actually hide the label. So if that's off, then our label will disappear and we will actually have a float but that has no label, but technically the label does exist, it's just invisible. Okay, so that's the same as that. You see how basically everything in that list where we're able to alter it is the same in here, so we can essentially fully define how this float should look and behave. Join with next is in there, so that means that it will put the next parameter after it will actually come next to it over here instead of underneath it. There's the help, so if you hover over it, what help does it define, right? At the moment it's got no help file, but we can type a help for it. It's got a script callback, which we'll actually be using in future. We'll be doing callback scripts on parameters, so as we change this, it runs a script. So we can define the callback script language. And then there are also tags, which allows us to define a whole lot of different things. So we can actually look at what the tags does, and you'll see it allows us to change a whole bunch of different things, right? So there's a dictionary with additional data that's stored in, and it uses that data to define how this parameter works. And then there's also a default expression and default expression language. So that's if it has an expression by default instead of a normal value. Okay, so that's quite a mouthful, but what you'll find is now a lot of these are in common across these. Not all of them are the same. Buttons, for example, will not have a number of components because there's only just one button, but for the most part, you'll find similar kind of functions across all of these, as, like arguments, which is a way of defining the initial state of that parameter template. So in our case, we're just going to give it a name, a label, and a number of components, because those are the three that we have to give it over here, and then we're going to stop. So we've defined a new float POM template. So if I print my float, what's going to happen is it's going to print a reference to that. Now it has a my float, it's got a label, it's got a length of 1, it's got a naming scheme, and all these kind of default values. But where is this? I mean, it's on none of our actual parameter lists. It's not on any nodes. Where is it? Remember that these parameter templates are just floating around. Okay, they're just stored in a variable. So this right here is exactly where it lives, and only there. We haven't added it to our Palm template group. And even our Palm template group is just floating around and stored in a variable. Okay, the parameters that are on this node are from an old parameter template group. But when we created it from the definition, we created a copy of it. So we're still working just within the Python scripting, just within these variables. We have a copy of the Palm template group, and we have this random sort of floating float. What we would need to do is store this float inside of this group, and then go and set on our node or our definition, depending on which way we want to go. We then choose which group to use as its list of parameters. And so when we point to this one that we've made alterations to, it will add the parameters to the node. Okay, so let's talk about doing that now. We've got a float, and we're going to come back to this just now. But for now, just remember that that's floating around there. Okay. But what we want to do is basically go and add this into the group. Before we even do that, there are some additional things we can do. I just want to point out that when creating this init, okay, there's a lot of things that we can define when creating the float. But sometimes you want to grab a float that already exists and maybe alter it. So there are also ways of manipulating these parameter templates that already exist. And since we have a reference to it, we can say myFloat dot, okay, and then run functions. So on our float palm template class, we can look at what we have available here. Now, some of them are asking questions. They're querying things. For example, default value. What that is doing is returning the default value. So it's asking this float palm template, what is your default value? But with a lot of these, there is a question, and then there is a command. So default value is saying, what is your default value? But set default value is saying, I am now telling you what your new default value is. And you can override what the default value was, right? So over here, we hadn't defined it. We just left it to its own default. And so its default value is actually 0, okay? But it's a tuple of 0, comma, and then nothing, because it's only 1 in length, but it wants a tuple because it could be longer in length. Okay. So what we can do now is go myFloat dot set default value, and then we can feed it our own tuple, but we can feed it a different one, maybe 3, comma, and then nothing. Okay. And now when we apply, and then we print myFloat. Okay. Let's just get rid of this for now. You're going to see still our same sort of floating palm template over here, but you'll see that the default value has been changed. Now that is true of almost all of the things that were created in the init. We can go and alter them as well. So default value, default expression, min value, min is strict, max is strict, the name, so we can ask name or set name, label, we can set a new label. We cannot set the type though. This is one important thing to note, is that this type is defining which type it is. So is it an int, a float, a string, a toggle, a button, whatever. We cannot just change the type, okay? We can ask what it is, and if we want to create a new one, we could go and grab, like let's say this was a float and we wanted to convert it to an integer, we would actually have to go and create a brand new integer and inherit as much as we could from this. So grab the name, grab the label, grab everything, but we have to define a brand new one. We cannot change type. But other than that, even the number of components we can ask or set. The naming scheme we can ask and set. The look, the help, hidden, so we can hide things or unhide them. We can change the script callback. Pretty much every part of that we defined, we can also change once we've created it already. Okay. So Now we've created one and we've manipulated it and changed it, and now we're happy with our float. Well, let's look at how we can add this into our PALM template group. Okay, so we can replace PALM templates. That's one of the first ways that I show you, and in fact that is what they reference in this list up here. Yeah, I think it's here. Yes, they talk about the replace function. So that's if you're wanting to actually alter a parameter in the PALM template group. What you really do is you grab a reference to one, and then you go and replace one that already exists with a new one or an altered one. Okay, so for example, if we want to, let's say on our label over here, okay, so PALM 3, we also want to maybe go and change this and change its label to something. So in here, I'm actually going to grab, I'm going to say, I'll just call it my PALM, right? So my PALM equals, and then we would grab a reference to that parameter. So we would say group.find. It's called PALM 3. So that would return a reference. If I print my PALM, we'll see that reference in here. Now we can alter it, because remember this this thing that we've got now, this reference is not the real one, but just a copy of it. So we go myPALM.set label, because we wanted to change the label to something else significant, something other than just label. So we'll change it to whatever. Okay. So again, if we print my PALM, you'll see that it's exactly the same as it used to be, except it now has a new label. And then when we go and actually set our PALM template group just now, when I show you how to do that, this will change. It'll change this one's label to be whatever. Okay, but only if we go and replace it in this group. So we could just add it into this group definition, but if we just add it, then we're going to still have this one called PALM 3 label, and we're going to add a new one called whatever, but it's going to try be PALM 3 and it's going to fail, so it's going to put it PALM 3_1, okay, which is not what we want. We want to go and replace this one. So we can say, we can go to our group, because it is a function of the PALM template group class. And if we find it here, replace. Now what this does is it lets us choose the name or PALM template or indices. Essentially, this first argument is asking, what do you want to replace? Like, not what do you want to replace it with. That's our second argument. But just tell me what you want to get rid of. But you can do it in multiple ways. So it's a very kind of dynamic argument. You can give it the name. So we can just say PALM 3. We can give it a PALM template. So in other words, an actual reference to that PALM template. Or we can give it the indices. So if we went and said find indices, and it returned that tuple of integers, in this case it would just be 0, because it's the first index and it is not inside of anything, so it's just on the root level, so it would be 0, then we could just feed it that tuple and it would find it as well. So essentially we just have to tell it what to get rid of. In this case, I'm just going to give it the name because that's probably the easiest. So I say group.replace, then we give it the name, so PALM 3, and then we give it what we want to replace it with. So my PALM, okay, which is this new altered version. Now, if I go and click apply, it's still printing this whatever one over here because we've got that print over here, but you see nothing changed here because again, we've only changed the group, but this group is a theoretical group at the moment, right? Like I said in the last lesson, it's kind of like that movie Face Off, right? We've got this kind of copy of like a face now, right? And we've made alterations to it, but the original, the patient is still on the table with their own original face. We actually have to go and like put this new one on. Okay, I know it's a bit of a gruesome metaphor, but it's like really because these parameters are the face of the node, and we need to go and we've got this separate face that we're altering, and then we're putting it onto the node. Now that's what the part that we still need to learn how to do is actually go and replace it, right? Well, it's something that we did in the end of the last lesson, which was going and setting the PALM template group. Okay, so in fact, why don't we do that? Since you guys already know how to do that, we have already covered it, so let's go do it. So on our group, we go group dot, oh no, sorry, it's not on our group, it's on our definition. So the definition of our node, which is a reference to the node and then its type and then its definition, that definition still holds true. That is a path to the actual definition on disk of where it's storing this HDA. So we go to that definition and say dot set PALM template group, and then we feed it the new group that we want to replace with its group, because it can only have one group at a time. So currently it has a group. There is no add PALM template group. There is only a set, because it can only have one face. Okay, so what we're doing now is we're literally swapping it with a new one. Okay, so now we feed it group. Okay, group was defined by what it used to be, but we've made alterations to the PALM template group. We've replaced something over here, and in fact with this one over here we're going to add this PALM template into here, and then we're going to run this function. Okay, so before we move on to actually defining this, I'm going to disable this for a second. This section over here, we took an old one that already existed and we replaced it. Here we've created a new floating one, but we haven't attached it yet, so let's go and attach this. So one of the ways of setting is we can, so there's a few functions actually that are going to help us. So I'm going to pop up the list here and show you. We'll find them in the PALM template group class. So under all of these functions at the top, which are all about finding and getting data, you'll now see there are ones that have, okay, so there's our replace, but then there is insert before, insert after, append, add PALM template, add to folder, and yeah, I think that's it. Yes, okay, so those are the ones we're looking at now. Now those are all pretty self-explanatory. Insert before just makes us give it, similar to replace, where we feed it an actual name or PALM template or index, okay, so a list of indices, and then this PALM template. But instead of replacing it with that one, it's going to insert it before that one. So that one will still be there, but it goes and inserts this before it, right? And then it doesn't matter where it is, inside of folders or whatever, it'll put it on the same level as this one that we've tell it, but just above it. And this insert after is exactly the same, but just afterwards. So for example, if we fed it PALM 3, it would go and insert it after PALM 3. Now, so we can insert before, insert after. Append is just going to add the PALM template after all existing PALM templates outside of any folder. That's important to note. So it's like adding it into root, but adding it into root at the bottom. After every single parameter, it will appear at the end at root level. Okay, so that's if we do append. And then add PALM template is simply an alias for the append method. So it does exactly the same thing. Then append to folder, though, that is similar to append, except it allows us to specify a folder, and therefore it will add it into that folder, but at the end of the folder. So if I wanted to add it into this folder name, it would add it at the end here under all four of these labels. Or if I wanted to click gave something, then it would add it in as the first one in this list. Okay, so we can choose exactly which one of these to do. Let's put it into this something folder. So first of all, we would need to grab a reference to something, and a way of doing that would just be to actually find the folder. So we're going to say group.find folder. Then remember, we give it a list of, so we say folder name, comma, something, right? And then let's print this. Okay, so we'll call it the something folder. That'll be my variable. So I'm just going to say print something folder, and I'll temporarily just disable all of that. So you see here, it does find our something folder. It has successfully found it. So what we can do is now say, let's append to folder. So we're going to say group, because we are altering our Palm template group. So we say group dot append to folder. Then the first argument is, okay, well, which folder, right? So it needs the label to that folder, or labels. So actually we could have fed it this list of labels, but sometimes I find it better to do a find first, because this will then have an actual error or return none if it doesn't find it. So it's a lot safer to actually grab a reference to it. But technically we could just take this, these two folder names or labels and put them in here. But instead we can give it the Palm template or indices. Okay, so we could have done the find indices for folder with this and then fed in those indices as well. But instead I'm just going to feed it the something folder reference, which is a Palm template. Okay, so in this list of possible, like 4 possible options, we're choosing this one, the Palm template. And then what we do is we feed it the Palm template that we want to add into that folder. So because we're wanting to append this Palm into this folder. And the one we're wanting to append is our float. So we call my float. All right. So let's click apply. Now this will actually be quite interesting. Although nothing's happening here, because again, we haven't set our Palm template group yet. But theoretically, that sort of, like I say, that detached face that we're busy altering and working on, okay, has my float added into its something folder. We can, once it's added in, we can go and grab a reference to it as though it's in that folder already, because it'll find it there. So we can double check that it exists before actually attaching the face, right? I hope you guys are enjoying this extended metaphor, because now every time I'm going to think of a face-off when I work with this. So we go group dot find, well, let's just do group dot find, and we'll look for a parameter called myFloat. Okay, because remember that's the name we gave it. So if we go and do group dot find and then let's print that, right? Then it's going to find myFloat. Okay. And in fact, if we ask for its, maybe let's find its indices, okay? So remember we have the find indices. So we say find indices, myFloat. What that's going to return is 110. So what that's saying is that it is, let's show invisible. It's at 1, so this is 0, this is 1, so it's inside of here. Then it is inside of 1, so this is 0, this is 1, and then it's at 0. So it's saying that it is the first index parameter inside of this folder. So even though we can't see it here yet, because we haven't attached the whole Palm template group to this node, it's essentially saying that it's finding itself on this theoretical Palm template group. Now, I know, guys, I know this is sometimes a little bit much, a little bit confusing, because you're working very blind. It's kind of like you have to almost understand what's happening here and imagine it before we then go and attach it, right? But that's why you do stuff like that, to check that it is actually working. So now, when we say definition.set Palm template group, what we're doing is taking the altered group and setting it to be this new Palm template group in the definition. So we're not changing the spare parameters, but actually changing the HDA itself. What changes have we done? Well, we've replaced Palm 3, which is this one, with my Palm, which is actually a copy of Palm 3, but with an altered label. Then we're also adding to the something folder, we're adding myFloat. What is myFloat? Well, it's a brand new float Palm template, but that we altered its default value. Okay, and then we're writing to the same definition as the original node. So we're replacing one face with another. Okay, so we click apply and look at what has happened. We've altered this parameter to be called whatever. It's still called Palm 3, but now inside of something is a float called myFloat. So we've altered that label and we've added one here. Okay. Now let's click apply again and see what happens. See, now it's going to error, which is something we have to be very careful with, because you see it's trying to add my float, but my float already exists. Okay, it's invalid because it already exists here. Okay, so if you're basically, we need to be very careful. We need to do a lot of checks. If we're going to go and add a new float or a new value, then we have to check what already exists. Okay, and remember when we said on here under HDA definition. So we'll have to just come over here all the way. In fact, I'm going to close a few of these. If we come to who.hda definition class and go to the set palm template group. Well, okay, I'm just going to search for it in here. Set palm template group. There is a rename conflicting palms function, argument over here. So let's go and say true for that. So set palm template group, we'll just say rename conflicting palms equals true. Then when we click apply, it adds another float, but it's called myFloat2, because this one was called myFloat. And now we can click again and it will happen again. Now technically every time it is also replacing this palm3 with a new one, but it's replacing it with a new one whose label is whatever, so it just happens to be replacing it with something that is identical. Okay, but it is actually replacing it every single time. It's not finding that it's the same and therefore doing nothing. So yeah, it's just important to know that that is literally being replaced. Okay. Now also you could take the I mean, this is where the metaphor of face-off really does hold up, is because here we're taking the face off of one person, altering it and putting it back on. But really what you could do is take it off of one and then put it on something else. So we grab the definition, we grab its palm template group, we make some alterations to that, but then we don't have to go and set it on the definition. Instead, we could go set it on our node over here. So here's our poor victim over here. So we're going to grab a reference to this node. So we'll just say n2 equals, okay. And then, so we've got a reference to that node. Instead of saying definition.setPalmTemplate, remember that setPalmTemplate group is both a function of HDA definitions and also of nodes. So we can say n2.setPalmTemplate group. So this will set all of this whole group as the spare parameters for our node. And we just need to check, does this version of this function also have rename conflicting palms? So let's just go and double check under who.node, and under who.node we search for set palm template group, and yes, rename conflicting palms is there as an argument, so this function should work. And then when we click apply, you'll see that it takes everything that existed as part of this, so our folder name, something, all the floats in here, and it sets them to this. Okay, so you see this has the whatever palm3 at the top, it's got our something floats from here. And in fact, it's got one more because it took this one, added one, and then added it here. So we literally took the face off of this and put it on this one. Okay. So that's kind of a disturbing metaphor, but yeah, that's basically how we work with parameters in Houdini. I know it is very sort of, sometimes it feels unnecessarily complicated, but once you wrap your head around it, it's really not that bad. Okay, you can create any parameters you want, and you then basically build up your palm template group and then save it as the palm template group of the node. Okay, so a very quick way, I know this is obviously a lot more complicated, but if we wanted to do a quick script to just add a parameter to a simple like node, so just a very simple add parameter function, you would still have to go, let's say, to our node. You'd say node n equals node, then you'd do you'd create a PARM template, so something like that one, but we'll call it something else, and we'll leave it as my float there. You'd say my PARM, okay, and then you'd still have to go to the group, so you'd go n dot PARM template group, because we're only altering, we don't have to go to the definition because we're not altering the HDA definition, but actually just the spare parameters. So you'd go group, you'd then go group dot append. So if you would just want to add it right to the end, then you append my PARM, and then you say n dot set PARM template group to be equal to group, okay? And then when we click apply, then it adds my float at the end here with a name something else, okay? So it is unfortunate that it's so convoluted just to add one parameter, but it's so complex because of the complexity of what happens when we want to add multiple parameters, or copy from one node to another, or copy it from spare parameters to the HDA, or the other way around. So there's a lot of a lot of crazy things we can do. Just one thing I want to also mention, which I actually forgot to mention before, is that you can also remove parameters. So let's say we did want to go and remove that parameter. There is also on your group, there is a remove function. So you can just, on the PARM template group, on our PARM template group, there is a remove function. So you just feed it the PARM template or name or indices, and it will actually remove that. Similar to replace, except instead of replacing it with something, it just replaces it with nothing. And then there's also a clear. So you could go and actually clear out an entire PARM template group, like just delete everything inside of it, and then go and set it as the PARM template group. So you're basically just deleting all parameters. It's the same as creating a brand new empty PARM template group and then just setting that as the group. Okay, so I really sincerely hope that helped and cleared up a lot of things, because this took me quite a long time when I first started learning Python and Houdini, how to kind of wrap my head around this took a while. But persist with it, please. If this is easy to you, then great, then I commend you. But if this is hard, just stick with it. It will make sense eventually. Repeat these lessons as often as you need to. Later on, we're going to be using this and actually building our own parameters. So you need to know how to do this. And in fact, in the next lesson, we're going to do an example so that this kind of makes more sense. Yeah, so I hope that helped, and I hope you all enjoyed. I'll see you guys in the next lesson where we'll put this into practice.